Hello guys, today I'm just making a video on some basic insights on how to solve questions related to truth table and logic gate diagrams. So this is just going to be a short video on how to just draw them and how to interpret truth tables. Alright, so if you guys have enjoyed the video, please do like, share and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so the question is asking us to complete the truth table for each of the following two logic gates. So as we can see here that there's an OR gate with a circle in front of it. So that means that this is going to be a NOR gate. So since this is a NOR gate, whatever we add, we have to just do the inverse of that. So what I mean by that is if we have 0 plus 0 is going to give us a 1, and we're just going to inverse that to get 0. If we have 0 plus 1 and we get 1, we have to just inverse that to get 0. We have 1 plus 0 is equal to 1. We just inverse that to get 0. If we have 1 plus 1, that's going to give us 1. We just inverse that, and that itself is a 0. Sorry guys, 0 plus 0 is actually a 0. So that's just a mix up there. This is going to be 1 there inverse, okay? Whereas when you add 1 plus 0, that's going to be 1. When you have 1 plus 1, that's going to become 1. You just inverse all the digits. So here we have 1, 0, 0, 0. This is going to be your answer for about 1 mark. Now let's move on to the next diagram. Now the next diagram is that we can see that this is an AND gate, and this has a circle as well in it. So since there is a circle in front of this AND gate, that means that this is going to be a NAND gate. So what I mean by this is whatever we multiply, we have to inverse that. So what I mean by that is if we have 0 times 0, that's going to give us a 0, and we're going to inverse that to get 1. 0 times 1, that's going to be 0. We inverse that to get 1. We have 1 here, so we're going to multiply that by 0 to give us, there's a 0 value. We're going to get 1 there. 1 times 1, that's going to be 1. And if we inverse that, that's going to be 0. So the output digits is going to be 1, 1, 1, 0. Now this is also going to be your answer for about 1 mark. Now let's move on to the next question. Now this is more of a drawing the logic circuit. So we have to draw the logic circuit for the following logic expression. Here we can see that there are 3 input values A, B, and C, and there's an output of X. We can see that the logic expression is given. What I'm going to do is I'm going to convert this into a symbol equation. So we have X is equal to something that is not. That's just going to be a bar on top, and not A and B. So it's going to be A dot B, put in brackets. This is going to be not A and B, and C. So it's going to reduce the length of this bar. By the way, the bar just represents not. So here we have to draw A and B first. So that's going to be A combined with an AND gate. So that's going to be this value diagram here. This is going to be an AND gate. Since this is a not A and B, we're just going to draw a small triangle here with a circle just to represent the not symbol. Once we do that, we have AND C. So we're just going to draw a straight line all the way connecting the values of A and B, which have been inversed. So we're just going to draw an AND gate again. Once you draw that AND gate, what we're going to do is this whole answer, let's say this whole value is also going to be a not. So we're just going to draw another NOT gate. So we're just going to draw something like this, connection points here. So it's going to be 0, and we draw it straight to the output. So as we can see here that this is an AND gate, this is a NOT gate, this is an AND gate, and this is a NOT gate for these values. So we can see that A and B also goes here, and we can see they both inverse to give us A dot B, which is not, and we have an AND gate, so this seems to be correct. Yeah, so this is your answer for about 2 marks. You can also draw the diagram like this. If you have A and B, you can also draw it like this with a NAND gate symbol. You can connect C's value with another NAND gate as well, and you can get the value of X. This diagram is also acceptable. So you guys can draw any diagram you guys like, whether it be this diagram or the other diagram. Right, this seems to be about it for the logic gates and truth table description, how to draw them and how to analyze them. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. I think that's it. Alright, new content will be posted soon, and right, bye guys.